Okay. Hi, everyone. I'm Chia-Hao Lee. I'm from Cornell University working as a postdoc. And thanks for watching this video. In this video, I'm going to talk about a general introduction of PtyRAD, which is the newly developed typographic reconstruction package that's using the power of automatic differentiation with PyTorch. You can do a lot of beautiful things, and now I'm just going to give you a general introduction of PtyRAD. So first of all, here's the outline. In this video, I'm going to talk about what is PtyRAD and why do you want to use PtyRAD? And then we're going to move on to how does PtyRAD actually work? And everything's going to be very high level because we actually make a series of videos that's going to get into more details of how would you use PtyRAD and how to get the result that you will want. And all these lovely details will be coming out later. And lastly, I'm going to cover some of the useful resources that you want to check out so that you can get started in a smooth way. So the very first question is, what is PtyRAD? So like I said, PtyRAD is a typographic reconstruction package. So that means it does typography stuff. So if you're familiar or you just got into this field, typography is currently the hottest imaging technique that can actually let you achieve the highest spatial resolution that actually won the Guinness World Record of the highest resolution microscope twice in a row, which is very amazing. And the fundamental principle to doing it is, first of all, you gotta have an electron microscope setup that you will want to collect a two-dimensional diffraction pattern at each scan position. So overall speaking, you're gonna get a 2D multiplied by 2D, ends up getting you a 4D data set. And once you collect this four-dimensional diffraction pattern, you collect all these information that you will need to process with something called like a typography package. For example, PtyRAD will be one example here that with this typography package, you will be able to unroll and to reveal the information encoded in the diffraction pattern such that you can reconstruct a high resolution three-dimensional crystal that's correspond to your specimen in your experiment. So this is how typography work, and you can see that once you collect the data, the key to achieve a high spatial resolution result is actually the typography package that you use, and that's where PtyRAD is designed for. So you may be wondering, why do you want to use PtyRAD? There must be a bunch of available packages, right? And you are absolutely right. There are definitely a lot of available typography packages. I'm just listing a few of these, and some of them have been in the field for quite a long time and achieved a lot of amazing results. And definitely this list is still growing and growing. And PtyRAD is just kind of like one of the example. So why am I even building a new software here? And the reason is PtyRAD is designed to be accessible across platforms. For example, if you are using Tycho shows that's known, AKA full slice, that it requires a MATLAB license, which can be quite expensive. Like I'm paying $400 or $500 per year to just use MATLAB license. And also PtyRAD is built on PyTorch, which is accessible across Windows, Mac, and Linux. Unlike other machine learning framework, like for example, JAX might only be available on certain platforms. And second of all, PtyRAD is very flexible and streamlined. That means we actually implemented a lot of configurable options that you can choose different algorithms, choose different optimization approach, and you can pretty much do your pre-processing, initialization, typographic reconstruction, even hyperparameter tuning, everything inside PtyRAD. And lastly, and probably the most important part is PtyRAD itself is very performant in both the reconstruction quality and the reconstruction speed that we actually achieve up to 24 times faster on a tested condition against common software. So here's a quick table that's also included in our archive paper about like a package comparison in terms of our feature. You can see that in the top row, PtyRAD implemented multi-slice, mixed probe, and also position correction. That's pretty much true for all the major wonderful packages. But uniquely, PtyRAD also implemented mixed object, and also it allows you to correct your object tilt at each probe position. And another new thing is PtyRAD also implemented multi-GPU. So that means if you have humongous data or you are fortunate enough to have access to multiple GPUs, you will be able to use multi-GPU in Python to actually accelerate your reconstruction process. So in all, PtyRAD is a package that actually integrates all these features in Python so that it's accessible to a lot of users. So here's just like some quick result that's also adapted from the archive paper that when we compare with other package, you can see that PtyRAD in the first two columns, it actually shows comparable or better result given the tested condition, but just in a fraction amount of time. So in this case, you can see that we're actually 10 to 20 times faster than other packages when we tested on a high-end A100 NVIDIA GPU. And of course, we want to kind of extend and see how this thing scales. So we actually tested on a bunch of different parameters ranging from different batch size, different number of promos, and different number of multi-slice layers. And you can see that PtyRAD, in this case, the blue curve and also the red curve, it all shows a pretty good scaling behavior, means that given the same amount of time, you will be able to test more different conditions, or you'll be able to run more iterations to reach the quality that you will want for your typographic reconstruction. And the last topic here will be how does PtyRAD actually works. So in this case, all these optimizable arrays, in this case, we're calling them tensors. We are forming them in a typical multi-slice approach, except that PtyRAD is designed to handle both mixed probe and mixed object at the same time. So following the typical multi-slice formalism, you are having your probe, and given a specific probe position, you choose your multi-slice propagator that's defined by your local tilt and your layer thickness, multiplying by your mixed object here. This is called forward pass, and you'll be forming all these exit waves with different combination of your mixed probes and mixed object. In this case, if you have 3 probes and 3 objects, you'll be forming 9 exit waves at the exit plane. And after that, you just do a far field diffraction to propagate your exit wave to your detector. You sum all these intensity up, you get the simulated diffraction pattern. Then you compare with your experimental pattern, you get the loss function, you pass it through your optimizer. Once you pass through the optimizer, the loss value will be propagating back and fill the gradient on all these participated tensors. And this whole process is called automatic differentiation because all these variables are connected with each other using fundamental algebraic operations. And this automatic differentiation is actually the backbone of this critically important algorithm called backpropagation in modern machine learning community. So here, once you do this backward path, which is marked in the red arrow, you will be getting gradients automatically from the backward path. This is where the magic comes in, because with automatic differentiation, that means we have the flexibility to incorporate a lot of these parameters to optimize. For example, you can actually optimize the local object tilt, and you can also optimize the layer thickness using this automatic differentiation approach, which is not possible previously in other conventional iterative typographic reconstruction method. And so this whole loop is called update step, and usually we update it with a group of diffraction patterns using optimizers here, which is basically just optimization algorithm. And once you pass through all the diffraction pattern, in this case, we call them one iteration, we'll be applying some physical constraints. So once you're done with your physical constraint, that's just one iteration. And usually you run 100 to a few hundred iterations until you reach convergence. And on top of this, PtyRAD also have another layer of optimization, which is using hyperparameter tuning that allows you to optimize certain variables that's not directly optimizable with automatic differentiation. For example, the learning rate, the batch size, and the choice of the optimizer, and a lot of other, for example, initial parameters like defocus, convergence angle, and things like that. So you can see that PtyRAD is a very streamlined package that encapsulated all these features nicely together. So that's pretty much how this works in a high level, and we'll definitely be making more videos about the details like how AD work and how what are the constraints that we're having, and how should you choose optimizers and things like that. Lastly, we just want to briefly cover the available resources that you should definitely check out if you want to learn more about how to use PtyRAD and how to get better at PtyRAD. And definitely we'll be filling more and more information here. So I'm gonna move on to this. So you can see that, so of course you will want to check out the PtyRAD GitHub repo that's just under username Chia-Hao3 slash PtyRAD. You can see that we have a lot of README, and also you can pretty much just see the source code. And if you want, you can actually turn on notifications. So every time when I have a new commit, you'll be able to see it. And if you just want to know how to better use PtyRAD, actually, I will recommend you to read these comments that I put into a demo parameter file that actually tells you what are the available options and what they do in terms of configuring PtyRAD. And PtyRAD is actually configured with just a single parameter file. So everything you need to decide to choose to configure your reconstruction will be defined in this single parameter file. It's quite lengthy, but you only need around 10 to 15 fields to actually start a reconstruction. And the rest of them, you can just let PtyRAD choose the default value. And of course, PtyRAD has a documentation website that actually covers a lot of great tutorial thinking, including how would you do the installation. It's very handy. And if you want to know more about PtyRAD in the theoretical side, there actually this archive paper we put it on. There you can kind of see more discussion about the figures and the benchmarking that I just showed you in the video. And lastly, we're still making more videos, including this one, and we're gonna put it on YouTube so that everyone can see it. Just search PtyRAD official, you will be able to see these videos and the future videos. And lastly, we have a box folder that actually contains the previous tutorial video that I made during the internal testing, and also a lot of these tutorial slides that I made throughout the time. So these are all great resources for you to use. And that's pretty much it for this entire video. Thank you very much for watching it. Feel free to reach out if you have any questions. Thank you.